Hi, I'm Jeff Mandel, and I want to present my poster, A Pharmacoepidemiologic Approach to Propofol Delivery During EGD. I have no conflicts of interest. Endoscopic sedation is a task commonly performed by anesthesia providers, even when they have no understanding of pharmacokinetics. In high-volume locations, providers will adjust dosing patterns to minimize adverse events from inadequate or excessive sedation. A control strategy determined from pharmacoepidemiologic analysis that is equally naive about pharmacokinetics may prove useful. Design principles. At every point in time, there's a probability distribution for delivered propofol at that time. Patients live on an isopleth. A patient who requires the 99th percentile dose to lose consciousness probably requires the 99th percentile dose to remain unconscious. And with a large enough cohort, a subcohort of similar patients can be constructed for determining the isopleths. IRB approval was obtained to review 13,503 upper endoscopies performed at Penn over a 2-year period from a de-identified data store. Delivered propofol was determined at 1-minute intervals. Cumulative probability distribution was estimated at each time, and propofol isopleths were derived from this, as demonstrated in the next slide. You can see the cumulative probability functions over time. We rotate the coordinate axis, and we can see the isopleths ranging from 0.9 down to 0.1. If we isolate a single isopleth, in this case the 50th percentile, we can see that an initial bolus of 102 milligrams followed by 198 mics per kilo per minute will bring us to 308 milligrams, the median dose at that time. Now there are two problems with this approach. How do we adjust for age and weight? And how do we know the sensitivity before initiating sedation? To address these, we'll form subcohorts. We can see that over the 90th percentile range for the data set, we have a range of 25 to 79 years and 51 to 120 kilograms. And over this range, it's possible to form a subcohort of 100 patients with an average standard deviation of 1.2 years and 1.4 kilograms. To find the sensitivity, we select a time to traverse a low-ranking isopleth, for example 25th percentile at 1 minute, and a high-ranking isopleth, say 75th percentile at 3 minutes. We connect the dots to yield a bolus over time followed by an infusion, and proceed until adequate sedation is observed. You can see here the 25th percentile and the 75th percentile, and the control sequence comprised of an initial dose of 1260 mics per kilo per minute and 300 mics per kilo per minute delivered until we obtain adequate sedation. Once we have adequate sedation, we note the amount of propofol required to produce this, determine the isopleth associated with that dose, and change the infusion rate to match that of the isopleth. Here's our 50th percentile isopleth, and our control sequence, which passes through 128.5 milligrams at 2 minutes and 9 seconds, and is followed by 128.2 mics per kilo per minute. What are the advantages of this approach? Subcohorts can be formed using information other than just age and weight. The aggressiveness of the controller can be adjusted by using different choices of times to traverse the isopleths. And control is based on experience. Improvements in control yield improvements in the experience base, and improvements in the experience base yield improvements in control. So the controller evolves over time to a more robust understanding of what the patients are doing. And finally, the only requirement to produce this is a pump that can deliver a bolus over a specified time, followed by a continuous infusion. And I thank you, and I'll answer any questions.